Okay. Okay. So now, as for the applied science, so applied mathematics actually, we will start from the vectors. What are the things you have already learned in vectors? What do you know? Anything? Can you hear me?
Yeah.
Oh, okay. So what are the things you have already learned?
It has direction and magnitude.
Okay, directions, magnitudes, and everything you have already learned. What about the planes? Two planes, 2D, 3D ones. Have you learned those stuffs? No.
No.
And for the dot products and the cross products, so those ones? Yes.
Products.
Yes, dot product and the those ones also no, right? A dot
No.
B and that's that kind of situation? No. Okay. Okay, that's totally fine. So now today we are starting the applied mathematics one. So as for the first lesson, we are going to talk about the vectors. Okay. So the first part is how we gonna define a vector. So for example, if you check here, you can see the vector A will be on this side and vector B will be on this side. Okay, so here, okay, before that, tell me a vector means what? Vector means what? What are the properties we have in vectors? When it comes to vector, there are two qualities.
Magnitude and direction.
Yes, very good. So how it differ, how this vector differ from a scalar, that is scalar we have only magnitude, but for the vectors we have both magnitude as well as the directions. That's the difference in between these two, the vector and the scalar. Okay. So here now what will happen? So let's assume how we denote these vectors. So to denote these vectors, we have to draw a line like this, and also not only the line itself, we need to mark the direction as well on that line itself, from where to where that vector happens or vector lies. So to mark that, we need to have the arrow, what we call the arrow as well. Why we are using this arrow? To mark the direction. Okay. So here, if you check for this one, they have marked two vectors. One is vector A, one is vector A. Once the vector A, once it's ended, then they have already started the vector B. So here we have for vector A and vector B both, we have the direction as well as the magnitude as well. So what will happen if they ask us to calculate the total, or else so since here there are two vectors, what will happen if they ask us to find out the resultant force or the resultant vector? How we gonna find out that one?
A plus B.
Yes, how we generally how we gonna calculate that one? A, the vector A plus the vector B. Okay. That is true. And when it comes to applied mathematics, how we gonna do this one? So we have to start from a point, and also these two vectors should start from that point, or else those two vectors should come towards the point. It should be either starting from a same point and what we call the those two vectors should start from a same point and then move, or else what should be there, or else what will happen here, those two vectors should come towards that point. So for example, if we have the starting point like this, then the vector A should go like this and vector B should go like this. Or else what will happen? Those two vectors should those two vectors should come towards a point like this. Is it clear? It can't be
Yes.
it can't be like this way and this way. Is it clear what I'm saying?
Yes.
It should be starting from a point and then move, or else it should, those two vectors should come towards that point. See, now here, if we wanted to add these two vectors, what we have to do here is first we need to draw this curve. So here we have already start with this point. Vector A will be on this side and vector B will be on this side. Then, so if we wanted to add these two vectors, first we'll go with the vector A. Once it is entered, then we'll start this vector B. Actually, what we normally do, we just mark this vector A and vector B like this, and then we'll complete the parallelogram. We'll complete the parallelogram, and then we'll mark the other vectors as well. So then vector A plus vector B is equals to A plus B. A plus B vector, that is belongs to this line. Okay, that is belongs to this line. Yes. So
Yes.
that is from this side, A plus B. What will happen? What will happen if we start from this side? If I go through like this, then what would be the resultant force? It would be B plus A. So for this side, it would be vector A plus vector B. And for this side, it would be vector B plus vector A. Is it clear?
Yes.
Okay. Now, what do you wanted to know is, so as I told you, we normally denote these vectors by using an arrow. So here we have that vector A like this. If it's minus vector A, if it's like this, what will happen for this vector A? So vector A will be like this. If they ask us to draw the minus vector A, then what will happen? What we need to do, what we have to do, if it's minus.
So minus.
Huh?
Subtract.
Subtract, yes, subtract from the graph or chart itself. How we gonna mark this negative vector? Minus A. How we gonna mark this vector? Actually, so as we already talked that the vectors have both magnitude and the direction. So here vector A, if the vector A is like this, the minus vector A means actually the magnitude is same, but the direction, what will happen for the direction? Earlier it was positive, but now it's negative. What does that mean? What does that mean? That means the direction goes to the opposite. Is it clear what I'm saying?
Yes.
So if the vector A like this, then the minus vector A, we have the same magnitude but opposite direction. That's what A and minus A work. Okay? If the vector A looks like this, then the minus vector A will be with the same magnitude, but the direction is opposite. If it's 2A, then how we gonna mark this one? If it's 2A, so what about the direction? Direction is either this side, either the side vector A or minus A. If it's 2A, if it's vector 2A, what will happen? So we already drew vector A. So this 2A vector will lie in the same direction, but what about the magnitude? Magnitude will be 2 times.
Same as 2.
Yes, yes, magnitude will be 2 times. A times 2. Is it clear how it works?
Yes.
Okay, okay. So that's up to that. Now here we are learning the difference of the scalars and the vectors. So now what will happen? So scalar, these are kind of few definitions which we need to know. So here for the scalars and vectors, scalar is a physical quantity that has only magnitude. As I already told, if it's a scalar now, we only have a magnitude. But for the vectors, we have both magnitude as well as the direction. Same as the scalar, vector is also a kind of a physical quantity, but it has both magnitude as well as the directions. So what are the examples for scalars and what are the examples for vectors? For the scalars, tell me, what are the examples we have?
Speed, distance,
Yes,
time.
yes. So for the speed, uh, distance, time, power, work, volume, so all those things are considered as scalars. What about the vectors? What are the examples for vectors?
Velocity, acceleration, displacement.
Yes, yes. So those ones, they have both the magnitude and the direction, so that we call them as the vectors. So those are the two definitions which we need to know. Then now we are talking about vectors in R squared and vectors in R cube. What does that mean? R squared and R cube means here we are talking about the planes where these vectors lie. So definition first, the first definition is a vector U in R squared. R squared, now tell me whether it's a 2D plane or 3D plane. What do you think? If it's R squared,
2D.
yes, yes. So if it's R squared, then that means it's in actually what we call the 2D plane. But for the R cube now, what will happen there? It will be in which kind of a space? 3D space. Okay, 3D space. So here definition, a vector u in R squared, which means two space in any ordered pair of real numbers. So how we gonna denote these vector? I mean the vector u, it would be u1, u2. u1, u2 means it would be either x and y. So because that is 2D now, 2D means we have only two directions and two dimensions. So here it would be in 2D. If it's 3D, now 3D now what will happen? Here we have x, here we have y. So perpendicularly for these two, we have another one, but which we call dz. So we have three sides. Is it clear?
Yes.
Okay. So r squared and r cubed. So if it's a r squared one, then that vector will lie. That vector will be, we are denoting it as u1, u2, where those two u1 and u2 are real numbers. So here in a vector u, if it is in 3D space, which we called r cube, then for that vector, there we should have three real numbers. So for example, here if it's in 2D now, we have like 2i plus 3j, only I and j, which means two planes. But if it's in R cube, which means a cubic one, then there should be three planes. Three plane means actually here, for example, what does that mean? If I give you an example, 5i plus 4j plus 9z. Like this, there should be three real numbers. Is it clear?
Yes.
Okay. Now what will happen if it's for n space? What do you think? How many digits are there? How many real numbers are there to describe this entire vector, which is in n space? There should be how many numbers actually we need to mention?
N number.
Yes. N number of digits, right? So here
Yes.
vector in Rn, which means the n space. So the definition is an ordered n tuples of numbers, that is u is equals to u1, u2, u3 up until un. Is called a vector where, so the space belongs to u1, u2 to u3, un, which is in real numbers, called component vectors. Component of vector u. So we denoted it by r to the power of n. So that's how we are calculating, or we are defining for any vector, whether it's 2D or 3D or 4D or 5D or any vector. Okay, is it clear up to this point?
Yes.
Okay, now what will happen here? So, definition, any vector with initial point P, terminal point Q R. Okay, now we have kind of another thing. So, up to this point, it's clear. Now we are going to learn about few words. One is position vector. Have you heard about this position vector? No. Okay. So now a position vector means actually a vector with initial point at the origin. For example, let's assume all the vectors are starting from here, 0, O. We consider this as the origin. Then we marked vector A like this. Okay, vector A like this. Now, here we have the what we call the origin, not the origin. Yes, here we can say, here we have the origin, but now the vector A will be looks like this. What I wanted to show is let's assume that the ending point is capital A. Then the position vector means the vector with the initial point at the origin. So here the origin is O, and what is the vector there? We have the vector A. Now the position vector we denote it as OA as the simple A. Is it clear? Always, if it's a position vector, we need to start with the origin. Is it clear? Are you sure? Is it clear? No. Okay, give me 1 minute. We'll do a few examples from here. Okay, before that, we'll just continue. Let me share my entire screen with the okay, this one is my entire screen, and then entire screen. And then here I have this one, and then let me take the pen as well, so that I can draw and show you paint. Still is nobody. Okay. So what I was discussing, okay. So here we go. Now what will happen here? We need to talk about the position vectors now. If it's a position vector, what you need to know is actually the position vector always start with origin. Origin. The position vector always starts with origin. For example, let's assume here we have O and here we have A. On this line, what they are connecting, so there we have a vector with the magnitude. Actually there we will have kind of a force. The magnitude would be simple A. Then how we denote this one? OA vector is equals to simple A, right? Now what will happen here? This OA vector, always it's starting with the origin. For this one, we called it as a position vector. Position vector. So always what will happen here? The vector with the initial point at the origin. It might be OA or B or C. Always whatever we are considering as the origin, then there we need to start with this origin. As a standard anyway, we will be consider O as the origin in world 1. Is it clear?
Yeah.
Okay, this one, the position vector, it should always start with the origin. and it should go like OA, OB. So if we have O here, if we have A here, the OA vector will be like this. And then you need to mark the direction as well. Okay, that's how it
Yes.
works. Then any vector with initial point. For any kind of vector with initial point P and the terminal point Q. So here the starting point for an vector, for a vector, the starting point O, what we call it? We have given a special name.
Position vector.
Sorry?
Position vector.
Yeah, so this entire one is the position vector, but for this point O, the starting point, we called it as initial point, and the ending point, we called it as the terminal point. That's how normally we marked all these ones. පටන් ගන්න එක. So where we start, we are marking it as initial point, and the ending point, it will be the terminal point, that is Q. So that vector, how we denote this one as PQ vector. Normally, how this PQ vector we are generating, that is PQ is equals to PO plus OQ. Is it clear? See, PO plus OQ. So better you can keep it like OP, OP as well. Why? What's the reason? Normally, OP means the, what we call, OP means what? OP means the position vector, and it should always starts with the origin. So here you can use OP. If we change the direction of this, then we need to change the we need to put a negative also on that, because the direction got changed or opposite. So minus OP plus OQ. That is the final answer. So OQ means actually maybe, yeah, they haven't given. So here for the OQ, let's assume we take it as Q, then we have Q minus P. Q minus P as the PQ. Okay? Can you do this by yourself? How to write these vectors and stuffs? So that we can move to the next part. Is it clear? Can you hear me properly? Are you sure?
Yes. Yes.
Okay. Then up to this point, it's correct. So now look at the example one, how they have marked this example one. The example one. So here, the vector u directed from P to A, where the P coordinates are 4, -3, 1, and the Q coordinates are 6, 2, 5. So see, here we have 3 digits. 3 digit means these vectors are in 2D plane, or these vectors are in what we call the 3D plane. What is it? It's in 3D, right?
3D.
Yes, it's in 3D because here we have 3 digits. So for the point P, they have denoted this point P as 4 -3, 1. For the point Q, here we have 6, 2, and 5. Okay. Now what will happen if, so they have given us the points P and the Q. So we need to calculate the PQ vector. Now, from the origin itself, we can write this PQ vector as PO plus OQ. Is it clear? PQ means actually PO plus OQ. Is it clear?
Yes.
Now PO means actually minus times OP vector. I just changed this to the other way, then there should be negative as well. So to get the kind of an easy and the simplified answer. So here for PO, instead of PO plus OQ, now what will happen? I'm just considering it as minus OP. So minus OP plus OQ, that is, here we have minus P plus OQ means Q. There we have Q minus P.
Is minus OP and PO same?
Minus, no. Minus, okay. PQ, sorry, okay, let me get a new one. Good question. Are these two equal? Are these two equal? Vector PQ and QR. Sorry, QP. PQ and QP. Are these two vectors equal? So, if a vector becomes equal, that means both the magnitude and the direction should be same. Now here what will happen? What has happened?
Opposite.
Opposite, right? Yes, opposite. Then how it will what we call the how we can make it so that, okay, I'll give you this PQ and minus PQ. So this QP vector is actually equals to minus times PQ. See, if we change these two digits into Q, if we change these two digits, now earlier we had as QP, then we just change that digit into PQ. Okay, QP, PQ. Now what will happen if you are changing that digit like that, then we need to put a minus in front of that vector as well. Is it clear?
Yes.
Then the PQ vector is actually equals to minus times, okay? Minus times what?
OP.
Yes, yes. Here, PQ vector is equals to minus times QP. Okay. Now, check for,
So they're same.
so these two are same. Yes. Because here we have changed the what we call the direction, but then again we have multiplied it by minus as well. So then we will receive the same previous one, what we had, PQ. Okay?
Oh. Okay.
Okay. Now for the example one. How they have done this example one? Explain me. How they have done this example one? What they have asked us to do?
Find vector U direct from P to Q.
Yes. So how it works? Now, the example one is find a vector U directed from P to Q. Okay, directed from P to Q. Now we have to start from P and we have to Draw this until Q. So this one is the PQ vector, that is U. Find a vector U directed from P to Q, where they have given us the coordinates of the vector P, that is 4, -3, -1. Here we have the vector Q, well, not the vector Q, point Q as 6, 2, 5. Okay. So now what will happen? We need to calculate the PQ vector. So we know then we need to start with the origin. Okay, with the support of the origin, then we can write this PQ vector as PO plus OQ. Okay, PO plus OQ. Now what is PO? So PO means actually minus OP. Because I changed this PO to the other way, then we can easily find out the what we call the initial vectors, no? So that's why I just change it, position vectors. So now PO is equals to minus times OP plus OQ. That is, here we have minus P plus Q, that is Q minus P. So Q minus P, now then what you can do? Here we have to substitute the Q coordinates, and then from that we need to subtract the P coordinates, the vectors coordinates. Is it clear, the example one?
Why do you switch it?
Switch it? Switch where? Here I just,
Like P to Q.
yeah, so here what I did was actually I just write the positive one first. Q minus P, then it's easy now. So that's why I just changed these two. I mean minus P plus Q, I just changed it to Q minus P, that because, so I just wanted to keep the positive value here first. That's the reason. Okay?
Okay.
Okay. Then what will happen? Now you know how to do that. So the solution will be,
Wait.
yeah.
So if there's two same letter, you can remove letter like minus OP to P.
P is there, okay. PQ is equals to PO plus OQ. Then here for PO means actually minus times OP plus OQ. Then OQ means Q minus P. For OP, I just took that vector as P. Okay, then that is minus P plus Q. Minus P plus Q means that is Q minus P. Q minus P. Is it clear?
Yes.
Okay. Okay. So now check for the example 2. Check for the example 2 and explain me what they have done there. Is it clear what they have done? Now, in example 2, they have asked us to calculate the midpoint of the segment. So how we gonna do that one? So they have given the PQ vector. We already have that PQ vector. Okay, so here let's assume we have P, here we have Q, and the PQ vector, okay, that is 6, 2, 4. 6, 2, 4, that is PQ vector. So on this one, then they ask us to calculate the midpoint of the segment. How are we going to calculate the midpoint of the segment? So anyway, the midpoint would be what? Midpoint means?
Middle.
Middle, okay.
2.
How are we going to calculate that one? What do you think?
Divide everything by 2.
Yes, yes. Then what you need to do, since it's for the midpoint, midpoint means we have to divide this entire PQ to two equal segments now. Then what we need to do, we need to divide this PQ vector by 2. That is, then now the midpoint will be on from this PQ vector, that is 1, 2, 3. 1, 2, 3 means actually it would be from where PQ, the half of the PQ midpoint would be 3, 1, 2. Okay, 3, 1, 2. Then what we normally do, we need to find out the PQ vector first. So PQ vector first, how? PQ vector is PO plus OQ, which means here we have minus P plus Q. Then you will get the final answer as 6, 2, 4. Is it clear? Because we already have these two values, P and the Q. So for the position vectors, we can get that OP and OK values. And then what we need to do, we need to do the subtraction. Then we'll receive this 6, 2, 4 as the vector of this PQ. And then since they have asked us to calculate the midpoint of the segment, then we need to divide this P plus Q by 2. So P plus Q by 2 means here X plus A should divided by 2, Y plus B should divided by 2, and again Z plus 3, Z plus C should divided by 2. Then it will equals to 1, 2, 3. Is it clear what they have done here?
Yes.
No? Okay, okay. Then, okay, that's about it.
Why are we adding?
Yes, ask.
Why do we add,
Why do we add?
then divide?
Why do PQ plus Q, sorry, PO plus OQ?
Yeah.
Yes, so here we need to anyway divide this entire PQ vector by 2. No? So this PQ vector means, since they haven't directly mentioned that PQ vector's value, what? Oh, good. So what we have to do here is actually PQ vector means what? We need to consider it from the origin. So PQ vector means PO vector plus OQ vector. So here for the, yeah. So for the, here PO vector means that is minus OP vector. So minus OP plus OQ. Then the OP vector means P minus P plus, here OQ vector means Q, that is Q minus P. Is it clear?
Yes.
Okay. Now I'm giving you kind of a few questions. Before we are moving to the equality parts and stuffs. Okay. Can you do these two MCQ questions? Can you see this one? Okay, let me. The first MCQ. This you can see, right?
Yes.
The question. Send me the answer. Show me the what we call the. Show me what? Show me the calculations as well and send me the answer and the entire working as well. You can hear me, right?
Yes.
Okay.
Mhm.
Try. What is the answer? Just try to work. So what they're asking? OABC and OABC. Here we have O, A, B and C. Okay. Okay. So here we have, oh, I just like that. That is correct. Here we have this one. All right. Okay. This one and this one. Okay. Okay. Now my question is OABD and OAED. OABC, no, OABC means this one. And OAED means the top part. Are identical parallelograms. Okay. Were you able to figure out?
Is the
No?
first one my is the first one minus AO?
Minus AO. So here what they are saying, OABC and OAED are identical parallelograms. The vectors P and Q are represented by. Okay, if I draw what they have mentioned, so here we have the two parallelograms like this. Okay, and so in the middle point here we have OA. So OAED parallelogram will be here. OABC parallelogram will be here. And then from here to here, we have that vector P. And from here to here, okay, from here to here, we have that vector Q. Since these two are identical parallelograms, what will happen? For this side also we have vector P. For this side also we have vector P. And for this side we have vector Q. Okay. Look at the arrow side. Okay. So, and from here to here, both two sides, again we have the same vector Q. This is how it marks. Now what they are asking, the vector P and Q are represented by the line segments OA, OA and OD. So what line segments represents the vectors? Okay. So OA and OD. So OA means
P.
OAP, right? OAP, yes. And OAP, then OD,
Q.
yes. Now, minus P vector. For minus P vector, what would be the, so for minus P, for this one, for minus P vector, what would be the line segment? Tell me. If it's minus
AO. Minus
AO,
AO.
not minus AO, that is OA, AO. Because OA vector, so for the OA line segment, there we have the vector P. Then if it's minus P, then if it is minus P, then we have AO, right?
Yeah.
Is
Hello?
it clear?
Yes.
Okay, now calculate for all those four. First one, second one, third one, and the fourth one.
So that means minus Q is DO.
Yes, yes, yes. Minus Q means DO, the line segment DO. Very good. If I write the answers for minus P vector, it would be AO, the line segment. And for the minus Q vector, that is DO. P plus Q. So for P plus Q,
OA plus OD.
P plus Q. Okay, so you can say P plus, okay, P plus Q means OA plus AE, no? So if it is P plus Q means here we have P, and for this side here we have Q. That is OA plus AE, which means we can say it in a single word, single segment, line segment, that is OE. Is it clear? So P plus Q, P plus Q, here we have O, here we have A, and here we have E, which means P plus Q means OA plus AE. OA plus AE means actually we have OE. OE is the P plus Q. Okay? Is it clear?
Yes.
Then the last one, fourth one. It's kind of a complicated. P minus Q minus P and then plus 2Q. Were you able to figure out? Go with the, go whatever they have mentioned. So here, with these two parallelograms, okay, so for this side we have P, for this side we have Q, no? So OA, ED, OAED, here we have B and C. Now what they are saying is, on a P minus Q. So minus Q now, it should be the other way, this side. OA plus, for this side, it would be minus Q, which means AB. Then P minus Q minus P. Minus P now again for this side. That is BC vector, BC line segment. Plus 2 times q. 2 times q means here we have q and also again we have another q. That is CO plus OD. Now if you work for these vectors, OA plus AB means OB, then OB plus BC plus CO plus OD. Now the next line it would be OB plus BC means OC. OC plus CO plus OC plus CO plus OD, right? Now what will happen? OC plus, then here we have OC plus CO. OC plus CO, these two will cut because magnitude is same but two different directions, right? Because this one OC, for this CO we can again rewrite it as minus OC. No? Then these two vectors will cut off, only OD vector will be there. So the answer is OD. Is it clear?
Yes.
Okay, that's how it works. Okay, then the first question done. Can you do the second question as well? Then we'll move to the rest of the theories. Try to do these 6. Actually, that's all for this one. Yeah. Question number 2.
First one.
Okay, first one run. Okay. The entire
How-
thing. Let me. So is it difficult? You need my help?
Yes.
Okay. So now what is the question? So the question is, ABCD is a parallelogram where the vectors P, Q, and R represented by the line segments AD. Okay, they have marked it AD, AO, AD, AO, and AB as shown. Write down the line segments that represents the following vectors. So 2Q minus P, that is
EO plus AO plus A.
Wait. You can simplify further, I think. So here 2 2Q minus P, no? 2Q means 2Q. 2Q means AO plus OC, 2Q. So the same thing because, so okay, let me draft this one. So this one is a parallelogram. Then, so this one is a parallelogram. And here we have the Q. What about these two? I mean, these two are equal in magnitude, right? I mean, AO and OC
Yeah.
in a parallelogram, the diagonals
Yes.
are intersecting equally, right? So here then this
Yeah.
is Q and also this one also Q. And this one we have DO. Then this one we have B, A. For this side we have R. For this side we have P. Then 2Q minus 2Q minus P. 2Q means AO plus OC. AO, I'm starting with A, AO plus OC. And then minus P. Minus P means we can rewrite this as minus P means CB. So here Q, again for this side Q. So for this side it's P now. For this side, let me get another color. For this side it's P. Then for this side it's minus P. Is it clear? So Q plus Q, that is AO plus OC, plus minus P means CB. Then AO plus OC, that is AC, AC plus CB. AC plus CB means AB. Is it clear?
Yes.
Okay. Then the next one. What about P plus R minus 2Q? P plus R, that is
I got
AC.
AD plus
Okay. AD plus DC.
DC
Yeah,
plus
AD plus DC minus
C.
CA.
Yeah,
Yeah, then the answer is
I got
0. Yeah.
AA
Huh? No,
or 0.
0. Yes, because AD plus DC again that's equals to AC, no? Then AC minus CA means, sorry, AC plus CA means AA. AA means we came to that same, what we call, we came to that same position, same initial point where we started. Is it clear?
Yeah.
Okay. Then you can do the rest now. We'll move to the next theory. I'll send you the entire questions, okay? So that part is done. Then this one also done. Let me first clear this one. How to clear this entire? Okay. No. I just need to erase this stuff. Okay. Now we already discussed these ones. Then we did this solution part as well. Yeah, that one you know, 1, 2, 3. And then you need to find out these coordinates. Yes, as a result, you can find out P and Q. Yes. Now, equality of vectors. I discussed this one. I told this one few minutes earlier. So, if it's equality of vectors means if two vectors are equal, that means what? Those, because when it comes to vectors, there we have two things. One is magnitude and the other one is the directions. So if those two vectors are equal, that means both the magnitudes and the direction is equal in those two vectors, right?
Yeah.
Magnitude equals as well as the direction also same in those two vectors. So here the definition, two vectors. They have defined these two vectors u and v, that is u, they have taken n arbitrary spaces. So here for the vector v also again they have considered n arbitrary spaces. So then if and only if, I double F means if and only if ui is equals to vi, so which means so all these planes, so each and every one should equals, so which means u1 vector should equals to v1 vector, u2 the second space vector should equals to v2, and then u3 should equals to v3, likewise up until un it should equals to vn. Okay, that's how it works. Is it clear? Both should equals respectively for the magnitude as well as the direction. That's what here they have mentioned. Are you clear with the notations?
Yes.
Okay. Okay. One other question. If and only if means? If and only if means in mathematics? What does that mean? In your words? What do you think? So if and only if means, because this one you need to remember that stuff. So if and only if means actually, if we define this one like this, if and only if means we represent like this. What does this means actually? These two, this is true either P and Q both are equal, or else either P and Q both are false. Is it clear? So to become this entire statement is true, then both P and Q should true, or else both P and Q should false. If and only if this happens only, if the left hand side happens only, the right hand side will happen. If the right hand side will happen, or if the right hand side is true, then exactly the left hand side also true, or it will happen. Is it clear that the if and only if means?
Yes.
Okay. Now that is it. Now the example 3, find the values of A, B, C if the vector U is in 6, A minus B, C plus C, and the vector B is A plus B minus 4, 9 are equal. Then what do you think? What we have to do? So those two U and V vectors are equal, which means the direction and the magnitude of these two vectors are equal. Then what are we going to do? So we just equalize these ones. So here 6 is equals to A plus B. The second space one, A minus B, is equals to this minus 4. And the third space one, that is C plus 3 should equals to this 9. If these two are equal, which means respectively ith, jth and z's, so here we have the 3D one, look, 3D one in the sense, so all these three respectively it should equal. So that means A plus B is equals to this 6, and the second space there we have A minus B is equals to minus 4, and here we have C plus 3, that is C plus 3 is equals to 9. Then we can find out A, B and C. Is it clear?
Yeah.
Okay. Then that is up to this equality of vectors. Then we have the addition and scalar multiplication. Addition and scalar multiplication. So here what will happen? So when it comes to addition and scalar multiplication, let's assume first we are doing the addition part. Okay. So we have two vectors to add. Vector 1, first vector is vector u, and the second vector is vector v. Vector u also representing kind of n space 1, and also vector v also in n space 1. Okay, so those two are in on the same plane. We'll say like that, same plane. If it is 2D, now 2D. If it is 3D, now both are in 3D. If it is 4D, now both are in 4D likewise. Then how does this addition and the scalar multiplication work? You have done the addition and the scalar multiplication earlier. What do you think? How are we going to add these two? We just need to add the respective values, right? U1 plus V1 and U2 plus V2 and U3 plus V3 likewise likewise up until the nth space. That's what here they have mentioned. So for example, if I show you vector u, that is 2i plus 5j. 2i plus 5j. Then vector v, we have 10i plus 9j. So u plus v vector, what's the final answer? U plus v vector, what is the final answer?
12i
12i plus
14j.
yes, 12i plus 14j, that is it. And if I do the scalar multiplication like this, let's assume we have u vector as 2i plus 5j. Then the scalar multiplication will be, let's assume we have 11u. I just multiplied this vector u from the scalar 11. What is the final answer? If it's 11 times u, the answer would be
22i
22i plus
55j.
5j? No,
55.
55j.
55.
Yeah, 55j. 55j. So that's what here they have mentioned. We need to multiply this k from each and every component of this vector. That's how we just mentioned these two. Is it clear up to this
Yes.
point?
Yes.
Okay. That's great. Then addition, right? Okay, this one. If the vectors a and b, if the vectors a and b are represented by, here we have vector a and here we have vector b, where the vector a magnitude of this length is 4 centimeters and the magnitude of this b, vector b, is 3 centimeters. Construct the following vectors. Can you do this one? 2a plus b. You need to construct this exactly what they have given, okay? So you need to measure this 45 degrees and then marked it, and also for the lengths as well. Can you do it now? You do it as a homework. Is it clear what they have asked you to do? No? So here what they have asked you to do is, so they have given the vector A and vector B. Vector A will be a horizontal vector and this length would be 4 centimeters. And for the vector B, it will be 45 degrees. And also the length of this vector, magnitude of this vector, they have given with the length, that is 3 centimeters. So then they have asked us to construct the following vectors. So the 2a plus b. How we gonna construct this one?
Six, 8 centimeter A.
You need to construct this one. First the vector.
So dot. So we have to
Yeah,
dot.
you need to draw. Then 2a means So if I draw it roughly here, we need to draw two horizontal lines like this. The all together, this should be 8 centimeters length. This is 2a. 2a plus b, no? 2a plus b means now what will happen? We have to start from here and then we need to measure 45 angles as well. Okay, let's assume now here we have 45. Then we need to go up until 3 centimeters. So here the length would be 3 centimeters. The angle is 45 degrees. So from here to here we have 8 centimeters. And then, so from here to here then we have 2p. So here we have q. They ask actually us to construct and add these two, which means we started from here, we ended up here. Then what we need to do? We need to map these two with a line, and then we need to what we call read the length from the ruler, and then this angle as well. That is the magnitude. Angle, no, angle also you have to mention. Is it clear?
Yes.
Okay. So the magnitude of this entire 2p plus q vector will be the length of this green color line. And for the direction, you need to say the direction as well by measuring this angle. This angle. Okay. So you need to show that one. As they have already shown it for the vector b, you need to show as well. Then you can do the third question as well complete. Third, fourth. Okay. Now, before going to these ones, we'll move to the theories. Okay. Now, we have already done up until the addition and the scalar multiplications. So, we did addition and the scalar multiplications. Now, what we are going to do, we are going to talk about the parallel lines. Give me 1 minute, I'll drink some water and come. Okay. Till I come, I have to go to the downstairs and drink some water and come. No? So, can you do another two from this? Sorry,
Okay.
2a plus b we already did, and a minus b, and also a plus 2b as well. Do this question. I will quickly bring some water and come. Give me 1 minute.
No.
Okay, done?
So I draw all of them, right?
Oh, you did all?
No, I'm supposed to draw all of them or just
You need to draw all of them, yes. You need to draw all
how?
of them. Sorry?
How do you draw a minus?
So minus means the same magnitude, but the direction is opposite. So they have mentioned that the vector B this side now with the 45 degrees minus B means for this side, the other way. But the length is same, but the direction will be this side. Then the angle is, this is 45, this one is 135 degrees. The opposite direction with the same length. Is it clear?
Okay, yeah.
Do one. Sorry. That is A minus B.
Yeah.
Okay. Is it clear, right? It's clear, right? Okay.
Yes.
We'll move to the next part. So then Now we did these two as well. Now, okay. So you had the question. So this was your question. So if we multiplied it from a scalar, then the vector u, so let's assume we have, okay. Now we are going to talk about the parallel lines. Okay. So for the parallel lines, what do you think, what's the quality of these parallel lines? Let's assume we have two vectors, that is u and v. So if those two vectors are parallel, that means what are the properties they have? If two lines
Two
are,
lines,
okay, let's say, tell me this, if two lines are parallel, what happens?
they don't touch.
No, it don't touch. It don't touch. And also the direction is same, right? Because it's never touch means actually the direction will be same. They are not getting closer. They will be anyway the what we call the direct distance of these two is same wherever we consider. So these two lines are not getting closer, or else we can say that these two are not getting intersecting. These two are not intersecting each other, which means the direction of these two lines are equal. So here for the vectors also, if two vectors are parallel, that means their direction is same, but not from the magnitude. Magnitude, it can be different because this one, let's assume the vector u like this. Okay, this one is the vector u, and here we have the vector v. Okay, see,
Yeah.
those two have the same direction, but you can see vector v is much larger, much bigger than vector u from the magnitude itself. Or else, okay? So then, if these two are parallel, we can write that as the vector u and vector v are parallel if and only if this vector u can written as k times vector v. K is a scalar which is in real numbers. V and u are vectors. Is it clear? So for example, it's like this vector A. So vector u, if the vector u is A කියලා හිතන්නකෝ, think that that is vector A, then vector V will be, okay, vector V will be 3 times A. See, those two are in same direction. Those two are in same direction, but what has happened? The vector v is much bigger than vector u. So we can write here vector v as 3 times vector u. If we can write this vector u and vector 3 as a scalar multiplication like this, then we can say these u and v vectors are parallel. Is it clear?
Yes.
Okay. Now we have to learn about two conditions. Two conditions of this k, that means of this scalar value. If this k is greater than 0, which means if this k is a positive number, positive value, then those two vectors are in same direction. if this k, the value of k is a negative number now, if it's a negative number, which means less than 0 now, then those two vectors are in opposite directions. Opposite directions. Okay, so one is to this side, the other one is to the other side. Okay, is it clear
Yes.
what they have mentioned?
Yes.
Okay, okay. Now the next part. We'll do another 5 to 10 minutes and then stop. So I'll send you this entire tude as well as the workings as well, so that you can do those workings by yourself. And if you have any doubts, you can ask from me. Okay, so here two vectors PQ and RS are said to be parallel. If there exists scalar K such that if those two are parallel, then we should write this vector PQ as K times vector RS. Okay, so PQ means now we know that is Q minus P. This Q minus P is equals to K minus S minus R. So where we can write this, OP is equals to, so the vector OP means P, vector OP means P, and vector OQ means Q, and vector OS means S. Vector, then we have vector OS, and then we have vector OR as R. That is
So this
what
O,
OR. OR means, O means the origin, the starting point. So the starting point,
like zero
origin.
zero,
Yeah, 0,
like
0.
zero.
Yes, 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 yes. 0, 0.
Mm,
The initial point exactly. 0, 0, 0 means if that one is in Cartesian plane, no? If not, we can say the starting point as the origin, the middle point. O. Okay.
yes.
Okay. Then what will happen here? PQ is equals to K times RS. If and only if PQ means, vector PQ means uh, Q minus P from the position vectors, we can derive this one, and that is equals to K times S minus R. So the position vectors always, that is OA, OB with the origin, starting with the origin. Position vector of A means we need to give the vector OA. Position vector B means we need to give the vector OB. Position vector C means we need to give the value OC. Okay, is it clear?
Yes.
Okay, that's how it works. So up to this point we have done. Then okay. Then here we have example 4, example 5, and example 6. Yes, you can do these examples by yourself, because on that tute also we did these ones now. So try these ones up until example 7. So tomorrow, as for the theories, PO will start the third unit, and then in applied we'll start the dot product, scalar product, and the rest of the ones. Okay, are we good? Is it clear for today's lesson? Because today only we started the applied. So is it clear? Were you able to figure out and were you able to understand those theories? Were you able to understand those theories?
Yes.
Okay, okay. Okay, then we'll see you tomorrow at the same time. Same time in the sense we'll sharply meet at 8 p.m. from SLT. Okay? I'll send you the tomorrow's link. So keep this link as for the recurrent link for each and every Fridays. The Zoom one. I'll share you the recording as well so that you can look for this recording. Okay?
So where will be the
Tomorrow's class. The link.
no where will the recording?
A recording I'll send tonight. I have to upload this one, but so I'll send this one. Once I upload this one, shall I send you as a YouTube link?
Yeah.
Is it okay or is it okay?
It's okay.
Okay.
Yes.
Okay, then I'll upload it to my YouTube and then I'll send you the YouTube link. Okay?
Okay.
Okay, okay. Then thank you so much for joining. See you tomorrow at the same time. From SLT, it's 8 p.m. Okay? Thank you. Bye.
Bye.
Bye.